Hello world, hello Pythonistas. It's great that you have tuned in to this particular session on a Saturday, and I'm really happy to have you all here. As the PyLadies people have already introduced me this well, I would like to directly go into the topic without much ado, since you guys are here for that. Let me just share my screen. Okay. Cool. Let me just tune into, yeah. So my topic is advancing in open source. I know that you, since you're already in this particular talk, then you must be already contributing to open source, creating pull requests, and driving the next big change in the world. So congratulations, you're on the right path, because yeah, open source is the future, and communities in open source help us grow. So one thing that I would like to tell about myself, apart from the things that the PyLadies people have already mentioned, is I'm an open source lover. That's all I would like to tell about myself, and I would really like to thank PyLadies for giving me an opportunity to share my knowledge in this platform. So yeah, first of all, I'm gonna share some tips and tricks about common issues that you might be facing as an open source contributor. So the first thing being solving merge conflicts. So I would say that merge conflicts is something that you might have already come across, and it's, trust me, whenever you're going to push and you suddenly see that this merge conflict and you're like, oh my god, why didn't I pull from the remote and see what were the changes and then push it. So this is something that is like a total pain, I would say. So these merge conflicts occur when we are sending pull requests to GitHub, or fetching remote changes from GitHub, or attempting to merge and rebase. So I have an example right here. Yeah. So here you can see that I have deliberately tried to create a merge conflict. That's not something that you must be very willing to do. So yeah, I have created a repo, and then I have changed the same file, and then in two different branches, and then I tried to branch the new branch to master. That's pretty much what I did. So as soon as I did this merge command right here, I got a conflict that you can see right here, auto merging my code, and then there's a conflict in my code.sh. So if you're using a code editor, then congratulations, you might be knowing about the conflicts very well. That is, just go to the repo, and beside the files that are conflicting, you will get this blue C command, because I'm using VS Code. There are other code editors as well. IntelliJ also shows merge conflict, so you needn't worry about that. So the next thing that you have to do is just click on any of these, like accept current change, incoming change, accept port changes, anything that will solve the conflicts. And so you must be already wondering that these are like mostly the same thing, but I like echo hello world in both the changes. But since I did it in two different branches, and then I tried to merge the second branch into the first, that's why I got this. So yeah, you can just select any of these. Mostly I'll be selecting like accept both changes, and then I'll just add and commit as usual, and then there you go, you already solved merge conflicts. So you can also solve it directly on GitHub. That is, we have this resolve merge conflicts button already available on GitHub. So the one thing that you have to do is you can directly go to GitHub, and then just do the same what you did here, and remove all the trailing dashes. I don't know what this is called, but for now I'm referring to it as dashes, and these equal to signs. So then you're good to go. You already served. Congratulations, you solved merge conflicts. So moving on to some other issue that you might be facing. Next thing is cherry picking comments. Since you're already into open source development, you must be aware that when you get the hang of it, the next time you see an issue, and if you happen to know how to solve it, then you get so excited, and then you directly fork it, clone it, and then then you just make the changes, see whether it's working, and then you commit it. And then you suddenly realize that suddenly something strikes you that, oh my God, I committed on the master branch. That's not something that you must be doing. That's not advisable. You must be creating you must create a feature branch and then create a pull request using that feature branch and not in the master itself. So yeah, so in that case, you don't have to, do a branch again and then do the changes. It's not required. You can just cherry pick commits from a specific branch and put it in another branch. So the way that you can do that is this command right here. That's called git cherry pick. So if you wanna do a git cherry pick, you just have to just write the command git cherry pick followed by the commit hash. It can be like 6 letters, so anything. So in this way, you can cherry pick a particular commit if you want to. And another thing is, if you want to cherry pick a range of commits, like range of commits in the sense sequential commits, yeah, range of sequential commits. The next thing that you have to do is git cherry pick initial commit hash followed by 2 dots followed by final commit hash. So yeah, this is all that you have to do. You needn't remember the exact commands. So software developers are known for copy pasting. So let's live up to that. So yeah, you can do this. You can cherry pick a range of sequential commits using this. But one thing is, if you want to include both the range commits, that is the initial commit and the final commit, this is not the command to do that. The command to do that is something that you can see right here is git cherry pick initial commit hash followed by it must be looking pretty much the same, but there's this cap command in between, this cap or hat command, whatever you call it, like hat symbol or cap symbol to do that. If you want to include both the initial commit and the final commit, that is the range commits. So in this way, you can cherry pick commits and then add them as usual to the next branch, and your job is done. Moving on to the next tip and trick on squashing commits. Yeah, one thing is, as a beginner, I used to, do a lot of commits for a single change, and then when I suddenly go back to the repo after a long time, then I'm like, okay, there's the single change, and I committed there are like 7 commits doing it. So that is just a way you must be, as a contributor, you must also be thinking that when maintainers and pull request reviewers ask you to squash commits, you must be thinking that they can do it anyway. Like they have a squash and merge button at their service, so why would they not do it themselves? That is just to keep the Git commit history clean. That is very important. You might not understand the importance of it right now as an open source beginner, but when you get back to your repo after 5 years, you'll be so happy that you learned how to squash commits and do it. So for that, needn't worry. Just there's a single command that you have to do that's called git rebase -I for interactive, followed by head, followed by tilde symbol. I don't know whether I'm pronouncing it correctly, but it's tilde symbol, I guess. Yeah, so tilde symbol followed by any number of commits. It can be 2, it can be 7. Let's take it n. So this will squash the last n commits that you have done. And one more thing is, if you want to change commits, for this you have to go to the git log and then remember the number of commits and then do that. But that must not be something that you would be wanting to do. You don't want to remember and go through all of that pain. So in that case, you can use git rebase -I followed by the last but one commit. The last commit that you want to squash, just the commit before that, just write the commit hash of that. Then you're good to go. You squash your commits. You chose to keep your commit history clean. That's great. So moving on. Okay, this is something that again depends on a case-by-case basis. That is dependency management using Git. So first of all, what do you do when you want to keep a child project as a part of the parent project? So what you do is you just keep it inside a folder and then just put the folder in the parent repository. Okay, that's good to go. But what if you have to, use the same child project in different parent projects. What you do, you just keep on copying it, copying the same child folder in different parent folder, and then building the parent folder and all of that. But again, if you want to change something in the child folder, then you'll have to go to all the parent folders and do the same. So that's not something that you would be wanting to do. And one more thing is, suppose you did some change in some parent folders, but you forgot to do the same changes in the other parent folders, and then you're suddenly like, okay, I did the change, and why is it not working? So that basically highlights the next issue that's called inability to build and test from bleeding at checkouts. So yeah, this seems to be a very long sentence, so I know that you might be confused regarding it, but it actually means the same, that something that you have changed, but the changes are not reflecting, then you're suddenly like, okay, how did this happen? So since suspense doesn't go down well with developers, I don't know about others, but it definitely doesn't go down well with me. So I'll directly jump into the solution. What if you could, use the child project as a Git repository and then just feed it to the parent repositories on the go, and then in case you want to change something in the child repository as well, you can directly change it, push it using the single command, and yeah, that's pretty much how we can do it. But we all know that Git helps manage source code, but there are some tools provided by Git itself which can help you achieve the same. So they are called Git subtrees and Git submodules. So the cliched way is going through the term itself, like clarifying the term. So this is a real life scenario of what we'll be discussing further. This is a picture of a cherry tree growing on top of a mulberry tree. Uh, that's not of much importance to you, but just an example. And if you are into botany, just feel free to to go into it and see how this takes place. So yeah, for the people who are already good at data structures and algorithms and are good at trees. So this is the joining figure for your use, that is using a part of a tree as a subtree and another parent tree. So this is what we are going to do. So the first tool that we are going to discuss is Git submodules. So Git submodules helps us nest Git repositories within another Git repository. And one more thing that I would like to say is it helps in this by pointing to a specific commit reference from the child repository. And this doesn't at all merge the whole child repository's commit history into the parent repository. So this is just a link that points to a specific commit in the child repository. And obviously it helps us overcome the disadvantage that we already discussed, that's ability to build and test from bleeding edge checkouts. And one more thing that you have to keep in mind while working with some modules is you always have to update them when you pull it, and then build the parent repository. So that's why I've mentioned here update specific submodules. A demo time. So I have an example of how this thing works on GitHub. Okay, okay. Okay, yeah, took some time. So I have a repository that I built specifically using submodules. This is called repository of submodules. So the first thing that you might have already noticed is a folder name is followed by @ followed by a commit hash. This is basically the the final commit in the master branch of the child repository. So if you click on it, it just leads to the child repository. So as I told earlier, living up to its name, it's just a link that points to the child repository. So I have three other submodules in this repo. And the next thing is, if you want to know whether a repository contains submodules, is okay. This is git modules config file. You can go there, and this is pretty much self-explanatory. That is, there is a submodule followed by a path followed by URL. So when you add something in the submodules using the terminal, this will be updated. So let me show you something on my command line. Okay, do I have an example? Yeah, I do. Okay, the command to do that is git submodule add followed by URL to the git repo. So let me just see whether I can add it. Suppose I'm adding this repo right here. So you just have to copy it. Then you have to just paste it here. So yeah, this is how you must be adding as a module. See, this is started. I don't want as a module, so that's why I stopped it. But anyways, this is the way that you have to add as a module, and then you have to initialize as a module. For that, you have to do git sub module init. So this is how you initialize a submodule after you cloned it. Then one more thing that you must be wondering is, suppose if I want to pull changes from a submodule, what I have to do? Only thing that you have to do is git submodule update. And one more thing is, it also, if you're thinking that if I have to point to like if I have to explicitly mention the exact commit that I want to point to, you needn't do that. You just have to do run a git submodule update, and that will pretty much update the commit hash for you as well. So this is how you can work with git submodules. So yeah, there's another tool that I would not say is a direct alternative to git submodules, but achieves something really similar. It was introduced in 1.7.11 version of Git, but I'm sorry to say that this is not available in the Git default package right now. It is available, but a different version of it is available. That's pretty much local and not decentralized. The thing that I will be talking about is decentralized Git subtrees. So this again helps achieve the same objective that we've been discussing, that is nesting child repository inside a parent repository. So yeah, so this is another way when you can inject and manage dependencies. So that is pretty much what Git subtrees do. The thing that I mentioned earlier is Git subtree is not available in the default package. If you want to, uh, you know, have the Git subtree with the exact config file that's called git trees, you have to directly install it from /contrib /subtree and the Git source code repository. So I'll just show you a demo. Okay, just keep doing it all the time. So yeah, this is something that I had set up a few months back. That is, as you can already see, there is this git trees config file. If you want to get this, then you have to download git subtrees from git source code repo that I already told you. I will be including links of that in the slides if you want to have a look. So yeah, moving on to the git trees config file is this is a git subtree right here. So you can see that it's a git subtree, then there's this URL, there's this path, and there is this branch. So using this, you can navigate to that. But if you click on it, you must be seeing that this is pretty much like any other simple folder. So it's pretty much really difficult to understand if there is a subtree unless there is a .git trees config file. So I'd highly recommend to use the one that is available on the Git source code repo if you want to have a Git trees config file. So yeah, this is the difference between Git subtrees and Git submodules. Git submodules just a link, but Git subtree is like clones the whole child repository inside the parent repository. Just clones, it has a whole copy of the child repository inside the parent repository. Another thing that I want to show you is when you go to the commits, then you can see that there are some of my commits, but there are commits by others as well. So this simply shows that Git subtrees merge the whole commit history of the child project into the parent project. So that pretty much explains what Git subtrees do. So I'll just show you how Git subtrees, how you can add a Git subtree to your parent repo. First thing is you have to add the repository as remote, like you do every time. That is git remote add origin, or maybe I'll just add a folder name. Let's git repo folder name, and then followed by the git repo URL. So this is pretty much what it does. And then you have to add the subtree using git subtree add -- prefix equal to folder name followed by git repo URL followed by the branch name. It's mostly master, but if you want to specify the branch to be something else, you can do that. So git subtree specifically requires the user to mention the branch, otherwise it won't be able to merge a tree with the parent repository. So it needs a branch. So this is how you can add a git subtree. Okay, moving on. If you do that, there will be a new entry in the git trees config file, and you'll see a new repository equal to this folder name in your parent repository. So you can also provide the path to the folder name, and the path will automatically be created in this particular case. And one thing is you can just add, if you want to pull changes from git subtrees, all the subtrees that's there inside the repo, you have to use, git subtree pull all. That's just a single command that you have to do. And push all. Similarly, we have push all for pushing commits into the child project. So yeah, this is how you can pretty much work around. You can get your hands dirty with it. I'll include the links in the slides itself if you want to have a look. So yeah, moving on. Okay. The thing that I have this section is the examples that I showed you on GitHub. It mainly dealt with documentation folders. And since we are already discussing about dependency management, it's very important for us to try it on dependencies. So I tried working on git subtrees on a repo called rules jbpm build bootstrap, which depends on 2022 dependencies, and I tried to add them as subtrees and then do a Maven build, and it worked fine. So this is the repo if you want to check out. And obviously, as I've discussed earlier, that these two approaches, git subtrees and git submodules, help eliminate redundancy and make maintenance easier. And obviously, if you want to use the same child repository and other parent repositories, as I already said, or just use a same child repository in different parent repositories. I'm basically telling the same thing, but yeah, it helps us publish in different platforms. And publish documentation on Wiki and on Gitbook. This is a specific use case for a single sourcing documentation. Moving on, this is like the main quintessential stuff that I have been trying to discuss. That is Git subtree versus Git submodules. As I already told, it will be very harder for beginners to know that a particular folder is pointing to a link, a particular folder link is pointing to a particular child repository. So it's harder for beginners to grasp. It was hard for me as well. But one thing is, it's available in the default Git package. You can check this out anytime. And whereas in Git subtrees, since the whole child repository commit history along with all the folders, all the files in the parent in the child repository is merged into the parent repository, it's very easy for beginners to find their way out. And another thing is Git submodule requires the child repository to be accessible in a server because it's a link. When you click on the link, it will be redirected to the child repository. So yeah, this is what you need if you're using submodules. And one more thing is Git subtree is decentralized because it is like independent now. You can because the whole new clone of the child repository is there inside, it's residing inside the parent repository, so it's decentralized. And one more thing that you might have already guessed is Git submodule provides a smaller repository size because they are just links. And whereas in case of Git subtrees, it's different because it just holds the entire child repository. So that's the reason why. If you want to have a look at the command differences between submodules and subtrees, I have attached a cheat sheet for you if you want to have a look. Moving on, since everything has its own pros and cons, I would say that the use of Git subtree and Git submodules would differ on a case-by-case basis. That is, Git subtree, I wouldn't say that it's a direct replacement of Git submodules. They have their own use cases. That is, if you have an external repository that you own and you are likely to push code to, then use Git submodules because it's very easier to push to Git submodules. And if you have third-party code that you're not likely to push to, obviously you need write access for that. But anyways, if you have third-party code that you are unlikely to push to, use Git subtrees because it's very easier to pull. It's just a simple command that's Git subtree pull all. Again, I said earlier, you needn't remember the commands. You can get it anytime. There's a plethora of tutorials available on the internet. Moving on to the next topic, that's setting up CICD. I don't know how many of you have already come across this, but they are just development approaches. You needn't fret on the thought of CI/CD, and they are not something very similar to rocket science, so you needn't worry about it. They just help us. Earlier, the approaches were different. There was this waterfall model that we all were following, that for every feature request, we were making sure that all the features are there, and then we used to build it, test it. But this led to a lot of surprises and challenges. As an adage goes, that if something is painful, do it more often. Then this will obviously reduce the pain points and obviously the surprises and the challenges that we are likely to face in production. So that's pretty much what CI/CD does. The main thing is CI is continuously integrate, that is continuously build and test every time you push even the slightest change or slightest feature request. Slightest feature, I would say. But in case of CD, that is continuous deployment, it takes a step further. It just deploys every time you push a feature into the main branch. So this, like the step further, it also helps us understand the changes in a production-like environment. So in this way, it helps us thrust automation and obviously reduces a lot of human intervention. I have an example right here. I'll keep doing this all the time, okay? So yeah, this is a simple repo that I've set up using Travis for syncing a repository with the wiki. I don't know whether you know much about the GitHub wiki stuff or not. That is, it helps us render documentation. So it's pretty much the same. Like this repo is synced with this wiki right here. So the thing is, you must be thinking that it's pretty much the same repo, then what is the need of syncing? You must know that this is completely unrelated, but some extra knowledge is GitHub Wiki is totally different. Like it has a completely different clone URL that you can see right here. This is a completely different clone URL, and this has a complete clone URL right here as well. So I had to set up a CI for getting this repo, like whatever is pushed to this repo or any pull request that is merged to this repo to be reflected in this particular wiki right here. So but you have to have this .travis.yml file that will basically handle your continuous integration stuff. So this is pretty much self-explanatory. That is, there is a script. This is mostly a bash script, and there is a set of commands. There's just configuring my username and email. Then I'm configuring the origin and then configuring the upstream. This is pretty much what I would have done otherwise if I wouldn't have chosen to automate, sync this particular repo with this wiki. So I just want to automate it. So this is just a list of commands that I would have otherwise manually typed on my terminal. So you can just accumulate all of them together in a particular script, bash script, and you can put them in right here. So this helps us. So this is pretty much what does my job of syncing this repo with the wiki. And there's this stuff, I know it shouldn't be here. It should be there in some, hidden env file, but sorry for that. I was in a hurry to get this working. So yeah, that is pretty much how you can set up a CI and CD as well, because I'm rendering it on a wiki. And this is somewhat unrelated, but wiki can hold multiple branches, but it only shows its own master branch. So it's if you want to show something on wiki, it's better if you commit it directly to master branch. And one more thing is this is also unrelated. That is, get reflected in the code. you can do that as well. So I've set up a nightly build user.is. Sorry, I don't know whether I'm pronouncing it correctly, but it's right here, like nightly.es. That is pretty much handling the syncing. The if you want, if you are pushing something to the wiki, it is also getting reflected in the repo. So I've set up a two-way repo wiki syncing with this. Moving on. Another thing that you might have already come across if you are into reading a lot of articles on the internet, that is building GitHub Actions. So what are GitHub Actions? For the people who don't know, and with the people who know, that's great. You must have already gotten your hands dirty with it. But yeah, GitHub Action helps triggers on events, and then it helps prepare environments, and then it runs workflows, and then reports results. That's pretty much what GitHub Actions do. So there are two types of GitHub Actions. That is, one is a Dockerfile action, and then the another is a JavaScript action. The Dockerfile action, the environment is defined by the container layers, and in case of Dockerfile action, the workflow is defined by the entry point. Bash script, oh, okay, I'm basically reading what's there right here, but you can just skip it. But one more thing is, I shouldn't be comparing both of them, but JavaScript action is what most people use because obviously, when you compare Docker with JavaScript, there are more developers who know JavaScript, and they are familiar with the syntax of JavaScript. So again, the environment is defined in the package.json in case of JavaScript action. And I shouldn't be actually comparing both of them, because if you have a Docker file in your system, that obviously won't work with JavaScript. So it again depends on a case-by-case basis. There are caveats. There are specific use cases where you would want to use a Dockerfile action, or you can choose to use a JavaScript action, whichever you want to use and whichever you want GitHub action for. So I have included demo time, obviously. I have included, if you want to get your hands dirty and see how I achieved creating a CICD pipeline using GitHub Actions, you can go to this link right here. Let me show you what I did. Okay. Yeah. So I have tried to set up a GitHub action of pushing React app to Heroku. So you can change, like the code structure is basically the same. If you are a React developer, you must be already familiar with this. So the only thing that I would be focusing on here is how to change your app into a GitHub action. So the lifeblood is obviously this .github folder right here, where you create your issue templates and pull request templates. And inside that, we have a workflows repo. And inside the workflows, we have ci.yml. You needn't name it CI, but it should be a YML file. So yeah, it should be a YML file. So I've named it ci.yml. Let's see what this does. Name is pretty much self-explanatory. Then we have on push branches master, that any change that you make to the master, any commit that you make to the master, this CI or this action will run every time you push changes to the master. And then we have this job, we have this build job, then that runs on Ubuntu latest, and there's this strategy followed by a matrix. Yeah. One more thing is I have used a matrix right here because we have two node versions that we want to deploy our app to. We have to make sure that the app works on both the node versions, that is 10.x and 8.x. So for this, for each of these, you have to make sure that the actions run for each of these node versions right here. Then you have steps, and then you have the uses of those steps. There are plenty of actions, and then you want to make sure that this is like checkout version 1, so just a name. And then you want to use a specific version that is pretty much self-explanatory, that is matrix.node version, because you have to run the same steps, same set of build steps for two different node versions. And then we have this uses, like for each node version, we have to do the same stuff. So this is like a for loop. That is, it will run once for 10.x and it will run once for 8.x. And then we have a set of steps that we want to run in both 10.x and 8.x. That is yarn install, yarn test, and yarn build. So yeah, this is if you've already known your way uh, through React, you already know what these commands do. So I didn't focus on that. So again, there is this thing called name add remote origin. This is just for deploying the same app to GitHub. That is, we just adding a Heroku origin, and then uh, these are secrets. I've added these secrets to the settings of this repo right here. And inside this secrets, we have two secret keys that we are using. So yeah, if you're wondering where it's coming from, just for your use. So yeah, so we are getting the secrets, API key, app name, and then we are deploying to Heroku using a similar command, just similar to what we use with Git. That is git push Heroku headmaster, and this there is a force push for it. So yeah, this is how I have achieved uh, making a GitHub action. I can show you how this works. That is, you can see that I have made two commits, and for two commits, we have two different builds. One is for build 10.x and one is for build 8.x. Uh, so these are just the jobs that run for each build. That is setting up job, then running actions using Node.js 10.x. That's pretty much what we wrote in the ci.yml file inside workflows inside .github. So it's just running the same thing. So if you want to have a look, you can just have a look at any of these. It's loading because yeah. So this is how this is the command that's exactly running for a particular name. So yeah, this is how I've set up GitHub action using this. Oh my God, I didn't realize that I have this GitHub academic discount coupon has expired. Oh my God. Okay, pardon me for that, but please focus on this part and not that part. Okay, so where I was. Yeah, the next thing is building GitHub bots. So you might have already come across GitHub bots while contributing to a particular repo. That is the most common GitHub bot that I have seen is you know, when you push to GitHub bot and there is this bot who reviews your pull request and suddenly like it is not according to the pull, it is not according to the coding standards of the repo. Then, and one more thing that I've noticed is one more bot that I've noticed is if a contributor hasn't signed the contributor agreement and it just shows that you guys are, hello contributor, you haven't signed this particular contributor agreement right here. So that's what GitHub bots do. So this is something that if you don't want to pay attention to, if you want to completely pay attention to collaboration and you don't want to, pay attention to trivial stuff which you would have already done. So the simple thing about bot is it brings automation and it makes sure that you don't waste your time doing something that could otherwise be automated. So GitHub bots extensively use GitHub webhooks and APIs. For the people who don't know what webhooks are, it's pretty much similar to a API. But one thing is we do in case of APIs we have to poll and wait for the API to bring in the latest changes. But in case of webhooks, it's just like brings in all the changes as soon as you push it. So yeah, webhooks are of great importance. So the most things that you would need to build a bot is available right here. That's the GitHub API version 3 documentation. You can go there and have a look. I have included it as a reference right here so that you can have a look. And if you wanna get your hands dirty and build a GitHub bot yourself, uh, I have this GitHub bot tutorial right here, so you can go there and have a look. So I'll show you. I have built a bot as well. I'll just show you the bot and what it does. This is pretty much the code base of the bot. Okay, sorry. This is page that opened all of a sudden. So there's this proc file because again I'm deploying the whole bot to Heroku. That is why I have this proc file. And then we have this create issue.py. This is a sample. So I'm using two libraries on Python. That one is async.io and the other is GitHub. So async.io is just to run concurrent code asynchronously using async await, which we already do on JavaScript. So if you wanna do something similar in Python, we can use these packages. And GitHub is used to call GitHub APIs. So this is just for GitHub APIs. So I tried to achieve a similar, like wrote a very simple bot that you might have that you might be able to see right here. This is very, very specific to the API version 3 documentation. You can just have a look there. Just there's this GitHub API followed by a session. This is my GitHub username, OAuth token. Is something that you have to get. And then you have this gh.post followed by the exact link followed by the data. So this is what this does is just creates an issue with this title right here that we got a problem, and with the body very similar to this. Not really similar, it's just the same, use more emoji. So I have used the GitHub CI repo that I already showed. So moving on to the issues, you can see, yeah, that we got an issue created by a bot. So one more thing is we cannot run bots like this. We have to have a server doing that for us. So for that, we have this repo right here. Not really a repo. We have this folder right here. And inside that, we have this main.py. So this is pretty much what we already did. And just this is just an enhancement. That is, we have basically used the same stuff. We have this issue opened event. And let me tell you what this bot does. This bot just goes to a person who has already created an issue. It just goes to the URL and just say thanks for reporting this issue, and I will look into it ASAP. So that's what it does. So this is also very, very specific to API version 3 documentation of GitHub. You can go there, just get the URL of the issue. That is event.data is the, you can say, a webhook payload of the event data. So inside this, we have issue. That just helps us, just accessing the JSON object. So this is very much, pretty much similar to JSON objects. That's what webhook payload looks like. And then we have this author, because we have to get the author directly from the issue itself. And so we have this message right here, and then we have this gh.post URL/data. That's pretty much similar, because we had earlier we already saw there was the title that's called "We Got a Problem," and then there was a body. So this is pretty much appending the same data. And then we have this post that handles pretty much the GitHub secret and GitHub auth token. So that's what it does. Just helps set up the post request and make sure that the post request status is 200. So that's what this pretty much does. So I ran this, and this is what I get. So I created an issue specifically to check this. You can see right here, issue to check bot. So this is something that got generated. Thanks for the report. @author. I will look into it ASAP. So I'm a bot. So yeah, you can just write simple bots like this with just a simple, just 2-3 lines of code. So this is great, actually. I didn't know that making bots was this easy. Otherwise, I would have tried it like way before. So this is just a very simple bot. I wouldn't say that this is an exhaustive list of bots. You can make similar bots. I have attached the tutorial. There are similar bots that you can build with this. So yeah, moving on. So there's another bot that I would like to talk about that I found very useful. That's called Epic Generator Bot. That is, if you've already worked with Jira provided by Atlassian, then you might have already come across Epic issues. That is, it is just a collection of issues. That it is like a big father issue, and inside that there may be issues. So it helps, map which child issues are there inside the parent issues. So GitHub doesn't provide anything similar to Epic issues. So there was this guy called Timon VS who created an Epic Generator bot. All you have to do is add an Epic label. You have to create an Epic label, and then you have to add it, and then just mention the issue numbers, just like you normally mentioned, that using hashtag. And then lo and behold, the epic issue is created. So I'll show you uh, the bot in action. I use the bot, obviously. Okay. So yeah, all I had to do is I just had to add the epic label followed by the issue numbers, and this issue right here is created. So yeah, this helps pretty much helps us gauge uh, what issues that we need to complete in order to read a certain in order to reach a particular milestone. So you can use this. So similarly, you can create issues. You can create bots and also create epic issues. Uh, we are slowly edging closer to the end of this session. I would like to end with the quote by Linus Torvalds that's called, "In real open source, you have the right to control your own destiny." Obviously, we have the right to control our own destiny. We can learn new stuff and make the most of our knowledge of Git and GitHub. So Linus Torvalds needs no further introduction. He is the creator and the principal developer of Linux kernel, so he has contributed a lot. So if you are wondering, obviously I'm a huge fan of Linus Torvalds. Otherwise, we uh, wouldn't have had Linux. So yeah. If you guys have questions, and if in case I don't reach out to you, you can find me in these particular channels right here. I'm like active on GitHub, and you can also ping me on Twitter. You can drop me a mail, anything that works for you. And so I would like to end with the note that we all are quarantined right now. I know how painful it is, and this is really, really important. And the situation is really perilous outside. And I know that you guys are getting bored and you cannot just watch lots of Netflix series. So I would highly recommend. I would not say that I have shown an exhaustive list that you can do with Git and GitHub, but I think that this is worth a try, and you can get your hands dirty and build something really useful. Uh, I've also provided the links, and with this, I would like to end this session by telling that keep learning, keep feeding your curiosity, and keep building new stuff. And yeah, happy open sourcing, happy coding. And one more thing is, once you learn something new, make sure that you lift others while you climb as well. So that's that's something that I'd like to stress on. So thanks for tuning in to this particular talk. Thanks, PyLDs, for giving me an opportunity to share my knowledge. Um, okay, that's pretty much that I had to share. Let me know if this was useful to you, and happy weekend. Bye-bye.